today. I am happy to kick your day off with a little bit of information about what we're doing at Lockheed Martin with AR. And my name is Christi Florentini. I'm a senior applications engineer at Lockheed Martin Aeronautics in Marietta, Georgia. And I'm going to talk to you about smart glasses and AR in aerospace manufacturing. And I'm really going to focus on finding the niche. So a senior applications engineer in this crowd, some people may think that I build apps, and that's not true. My background is actually mechanical engineering, and I work in our manufacturing technology group. So what we do is we are constantly looking for new technology to introduce to the manufacturing process. In the past, we've done major auto drills, we've done optical projection, small tools via 3D prototyping. So that's some of the stuff that we've done over the years, and now we're starting to venture into what is that next technology that's really going to enable us to improve our manufacturing process. So as a brief overview of what I'm going to talk with you guys today, so I'm going to cover what we do at LM Aeronautics. That hopefully some of you guys have an idea of what we do, but just so that you really understand the complexity of the work and why AR is useful and challenging at the same time. I'm going to tell you why we personally need AR and how that technology fits within the realm of our manufacturing process. And then I'm going to dig a little bit into some of the use case to technology matching that we're currently looking at right now. So what do we do at Lockheed Martin? Currently, we build the F-35, C-130, and F-16. Those are current production lines that we are building new aircraft every day. Why this is important? C-130, the first aircraft flew in 1955. We just delivered the 2,500th aircraft last year, and we've been building this airplane. It's the longest military manufacturing program in the world. So that is critical because think about where our designs came from. A lot of those are still in paper, PDFs scanned in, that still have a date of the last revision being 1958. That makes it challenging for us to introduce new technology, not just AR or smart glasses, really any technology that may require us to understand a little bit more about the design. Now you go over to F-35, or the Joint Strike Fighter, and we developed that airplane. The design started in 1996, and the first aircraft flew in 2006. So while it seems like a very new and relevant program, we didn't have AR really prevalent when we were designing that. So we did modernize the manufacturing process using automated guided vehicles, auto drills. We have a large part printer, like a laser jet printer that prints information on the aircraft, but we didn't have AR. So why this is important is because when somebody asks me, well, let's replace all of our work instructions with AR and tablets, I say, sorry, you're going to have to design a new aircraft in order for that to really work. Because we have thousands and thousands of designs that, yes, they're in CATIA, but converting that to something that makes sense for an AR solution is going to be so costly that we might as well build a new aircraft. So when we're looking at the next program, that makes sense. But today, we have to find opportunities of where this technology makes sense for specific areas where the cost or the return on investment is really beneficial for us. We also do some work in upgrades in the life cycle and our other programs that we've built throughout the year. Currently, we build wings for the P-3 in the Marietta plant that are being put on an older P-3 that has been pulled out of the desert and refurbished. We are wrapping up a program with the C-5 where we are putting new engines on it. So there's definitely a lot of work that can still happen with a lot of our programs. The F-35, we expect to have a life cycle through 2070. So there's opportunity beyond just the production floor, but the production floor is really where we're focusing our attention on right now. So why do we need augmented reality or smart glasses? Part of my job and part of our overall goal is to keep the mechanic or technician ship side. So hopefully you're familiar with the aerospace industry, but when I say ship, I mean airplane. And that's just the terminology that's thrown around a lot. Ship side means keeping that mechanic in his workspace so he doesn't have to walk over to his computer to pull up a drawing or a spec, or that he doesn't have to actually pull out a printed drawing, because we do use those still, even on the F-35. Even though it was all done in 3D CAD, we still print things out because it's very complex. So how do we keep them in that workspace so they are not having to have any wasted travel? So why is this important? Well, cost. It's huge. We are a defense contractor. So at the end of the day, you and me pay for these airplanes out of our tax dollars. So if we can reduce the cost, then it is better for all of us. It's better for my company, but it's better for us individuals as well. Affordability is a huge word in the industry, and we are constantly trying to cut costs out of our new program as well as our legacy programs, just because we need to keep selling these airplanes. Repeatability. This is huge as well. We work primarily with the union workforce, and the way that our operations are done, our work instructions, leave a lot of room for interpretation. It may say install clamps per blueprint, and there could be 60 clamps you have to install. So you have to go look through all these blueprints and figure out how you're going to install it. And you can install it left to right to left, middle out, any of these ways. So we leave that open to them, which is not necessarily the best way for manufacturing in this day and age. Improved training. So how do we bring that learning curve down? For F-35, we still are not at full rate production. So when we are trying to ramp up to that full rate production, we are bringing lots of people in, lots of new mechanics that have never touched this aircraft, and we need to improve and decrease their learning curve so that we don't have to take the experienced person off the job to teach them, and you lose productivity on both sides. And then finally, quality. All of these have some impact on quality. Quality is much more intangible for us and harder to determine, but at the end of the day, all of these things can help us improve our quality. So all of these things are the reason that we try to bring in new technology to improve this, and this is why AR is a really interesting technology for improving our manufacturing process. So I've told you a little bit about what we do and why we need more technology like this. But why does AR make sense? First, we have a highly complex product. Lots and lots of 3D models, drawings. It is just very comprehensive. Our supply chain is huge. But this is an aircraft that is sent into war zones. This is an aircraft that carries either cargo or is going out on missions, critical missions for our military. So there's a lot of complexity in each one of these. Also, we have a pretty manual assembly process. Even with the new modernized F-35, it's still pretty manual because it is complex, because it's very challenging to introduce automation in certain areas. So that is very skilled labor. How do we improve that skilled labor and help them do their job better? Extensive reference material. What do I mean by this? Well, we have lots of specifications that they have to reference, but the drawings. Just as an engineer, I try to go through these drawings that were designed like for the C-130 60 years ago, and you are just trying to figure out what this drawing says, where it references the next drawing. You could have to pull out 15 different drawings just to get the information you need to draw one hole. So when they're having to do that on the floor to do their job, it really makes a lot of sense to try and streamline this process. Also, there's some constrained workspaces. And when you think of a big cargo airplane, maybe you think, well, how can that be constrained? Well, when you start getting into the fuel tanks or even into the fuselage to try and do work, it's harder to bring in, say, a projector to provide them information. So how do we bring this contextual information to them in these constrained workspaces? And finally, we're not highly repeatable. This chart down below shows that last year we built 24 C-130s, 45 F-35s, in comparison to Boeing and Airbus, who built over 500 airplanes of the particular ones, the 737 and the A320. That's a huge difference. And that's just within the aero, right? So you start thinking about automotive, how many cars are the automotive industry is building a day. So even when we get to full rate on the F-35, I don't think it would be any more than 200 a year. It's still pretty low numbers. Our build process for a C-130 takes 9 days. So that person is doing work for 9 days and he starts over. It's not really repeatable, so sometimes bringing that information to them on that basis is helpful because they still have to reference the material because they don't do it as often as necessary. So when I started looking at augmented reality, which has been relatively recent, the biggest thing that struck me was how do we get this into our manufacturing plant? And that is trying to make sure that we are shifting the perception of the technology. So on one side, we have the skeptic. If you can imagine aeronautics industry, Lockheed Martin, we have lots of people that have been working there for 30 plus years, and they've seen everything that you can imagine trying to introduce, and they see this technology, and they say, there's no way this will ever work. How many have dealt with somebody like that? That's my job. On the other side, we have the technology enthusiast. We had a demo last July of some of this technology, and there was one gentleman in there who said, well, I just tried to buy some of those smart glasses, and they refused to let me have them, they being security. And I look at him and I say, did you think you were just going to buy them off the shelf and put them on and build an airplane? But we do have people like that. They expect this technology just work, and I can all of a sudden build an F-35 with smart glasses. And obviously, that's not reasonable, but we do have those people. So we need to shift to the ideal position, kind of in between. Understand where that technology does make sense. Understand that there is still constraints on it. Obviously, it's still an emerging technology. There's a lot of things that can still be developed, but it's also something we can use today. It is much more advanced than a lot of people think. And this is a problem because a few years ago, we tried to look at this before, and it was too far out. So people still think that. So you have to continue to bring that in to make them understand that it has developed enough that it is functional and useful, but maybe not across the board. So this is a big goal of mine, is trying to shift that perception. Cognitive bias is just a word that kind of means that when you have a perception of something, you stick to it. There's a lot of different examples of that, but it's a pretty interesting psychology concept that is hard to shift the way people think. So why are we in this position? I'm sure many of you have seen the Gartner hype cycle. This is the most recent one from 2015. And you can see wearables and augmented reality on this curve. So augmented reality has actually come down, and we're facing the trough of disillusionment. So what does that mean? Does it mean that we're all going to throw this away and it's never going to work? No, it means that it's just, we've tried pilots, we've done things, we've seen the technology, and we're like, yeah, but it wasn't as good as we hoped, right? So this is important because technology enthusiasts has now lost their momentum, and that skeptic is becoming more entrenched in what they think, and we really have to come out of that curve. And that is what is useful about these types of conferences, for us to talk about this, for us to develop these things and keep pushing forward and not lose our momentum, because soon we'll move into the right side of this curve, and hopefully it'll be an everyday thing where we're using augmented reality in manufacturing. So that chart kind of enters into this. We're reaching the big, scary chasm of technology. And this is where enterprise, like myself, needs to keep pushing forward and understand that if we can jump over this chasm and not fall into the river and drown below, then we will have success in implementing this technology and making our process better. So quickly, I want to tell you where does this fit into our manufacturing process. So overall, I've been looking at shop floor mobility. Like I said, bringing the mechanic ship side. This can be broken out for what I'm focusing on into projection, tablets, and wearables. So we currently have implemented optical and working on laser projection for various use cases. Or applications, right? I'm an applications engineer. We're also looking at tablets. Now there's standard use, like replacing your computer, and then there's AR. How do we enhance that experience? And then you start thinking about how do we bring in wearables? Is it augmented reality wearables? Is it information glancing? Is it maybe on a smartwatch where I can check off a quality check on my watch? So I'm just going to run through some of the use cases that we've identified and how we're starting to position them to fit into these, to match technologies with these use cases. So you can see across the board there's a variety. The orange is our C-130 use cases. Older airplane, fewer 3D models, so it's harder to implement something like AR. The blue ones are F-35. We do have 3D models, but you still have to do a lot of conversion and work to get to that point. Gray is our quality, and then P3 is another older plane like the C-130. So we've been working on identifying where does this technology fit? And what types of things make the most sense? So people have asked over the last day of, well, don't you think we could just put AR across everything? That doesn't make sense. I'm sure we can get there, but why would we need to? Why do we have to do that? When maybe optical projection works the best for C-130 wing because it's 45-foot long wing and we just need to project information up on the side of the wing. We've got great visibility, great place for projection. It's still augmented reality. Optical projection is augmenting your reality. Or, for instance, when we start looking at AR, what does a tablet make sense for, right? Maybe it makes sense for quality. That's a great use for AR on a tablet. But when we're doing work with both of our hands, you start to show that AR tablet and the mechanics will never use it. So it'll be a failed implementation. And we actually had that experience happen. I'll show you a quick proof of concept that we did. Unfortunately, I can't show you the video. But we went from this, paper, computer, and all of these tools, to this, everything housed in a pair of ODG Smartglasses. So what did that look like from his point of view? He had instructions on what to do. He had his part number. He had a graphic, and he had augmented overlays of the wire harness. That gray wire harness is actually a 3D model. So we were able to pull all of those things into a 3D version of his work instructions. And we saw about 15% productivity improvement. Although it was proof of concept, it was still a valid step forward of the technology does work today. Now it's a matter of all of those other challenges. But when the mechanic had this, he loved it. When the more, I guess, experienced engineer came out and saw it on a tablet, he was like, tablet is way better. And the mechanics just sat there in the corner and they were like, we never use a tablet. So you have to look at how does this make sense? Obviously, tablets may be a little bit easier to understand and see, but when you're doing work with both of your hands, tablets won't make sense. So we have to understand what does that use case look like? How does that technology match? And overall, it's a combination of all these technologies that give us more mobility on the shop floor. And quickly to wrap up, where I see our current obstacles. We do have obstacles on the technology side. We were doing video see-through with the smart glasses, and that was some negative feedback we did get. Battery life, we did so much processing, it only lasted about an hour and a half, so we had to strap them to an external battery, which was not so bad, but it was tethered. Marker recognition, obviously we can still have some improvements there. And no standards in the industry makes it hard for a company like Lockheed Martin to accept this technology and to go through the approval processes to get that hardware and software in the door. Because we are a big bureaucratic company and there is a lot of red tape to get through. But where I see the true challenges are on the organizational side. Like I said, red tape. Lack of standard work. We have to convert all of our work to step-by-step instructions for AR work instructions to work. We have to get optimized models because it's hard to convert CATIA to the 3D models that are used in an AR platform. Configuration control, what happens when we make a revision? And security challenges. That is probably the most difficult one we have. that we have to shift other than culture. So organizationally, this is where we're struggling, and I think that really makes it difficult for us to adapt this technology, but we still have to keep pushing forward because this is the wave of the future. Thank you.